Hey Caroline, thanks again for watching John the other night. Gosh, he just loves it when you come over. Anyway, we talked about factoring using the box method, and I had forgotten how to do that. But let me show you an example really quick. I looked it up and learned how to do it again. Let's say that we wanted to factor 4x squared minus 19x plus 12. First, we're going to draw our box. And right now, we're only going to focus on that 4x squared and the 12. The first thing we want to do is take the product of 4 and 12. So 4 times 12 is 48. And we want to think about which factors of 40a will subtract to give us 19. Well, they're going to add to give us 19. Just they're both going to be negative, because the negative times a negative will give us our positive 12. And we want a negative plus a negative to give us negative 19. So let's see, 1 and 48, 2 and 24, 3 and 16. Hey, those look good because we can do a negative 3 and a negative 16. So I'm going to put a negative 3x here and a negative 16x here. It really doesn't matter where you put them. I could have put the negative 3x at the bottom and then negative 16x at the top, and it would have worked just as fine. And we'll see why in a minute. Our next step is going to be to pull out the common factors, just like you and I did Wednesday night. Let's see, 3 and 12. And my leading coefficient here for my negative 3x, it's negative, so I'm going to pull out a negative 3 there. And then looking at my column, 4x squared minus 16x, 4x goes into both of those. Then looking at 4x squared and negative 3x, they both get an x. And then negative 16x and 12. Again, the first term that I'm looking at is negative, so I'm going to pull out a negative 4. Okay, so 4x minus 3 times x minus 4. And of course, I could FOIL this together to check my work. In fact, I'm going to do that just to be sure. 4 times x is 4x squared. 4x times negative 4 is negative 16x. Negative 3 times x is negative 3x. And negative 3 times negative 4 is positive 12. Yeah, this is going to work because we can combine our like terms here. Negative 16x minus 3x will give us that negative 19x that we're looking for. So that's an easy example with the box method. The one we were doing Wednesday night was a little bit harder. Let me get that one. So it turns out that both the mistakes that I made Wednesday night, I made because I copied down a part of the problem wrong. I dropped a negative sign on one, and on the other, I wrote down the wrong exponent. Anyway, this one works really well with the box if you copy it down correctly. I just must have been tired or something Wednesday because I didn't quite get it down right. So our first step when we're factoring is going to be to look for a common factor, and we did that. We did it correctly. We found that our greatest common factor in these three terms was negative 2x. So let me pull that out. X to the 5th divided by x is going to be x to the 4th. And our negative 2's cancel out. 58 divided by negative 2 is negative 29. And x to the 3rd divided by x is x squared. Then negative 200 divided by negative 2 is positive 100. And x divided by x is 1. So we don't need an x in that term anymore. So I'm just going to leave the negative 2x in front on its own right now, and the part in the parentheses is the part that we're going to put in the box. And we're going to use the same procedure we did before. So we're going to work with the x to the 4 and the 100, and then we need to think about what factors of 100 will add together to give us 29. They're both going to be negative again, since 29 is negative. So let's see, 100, we've got 1 and 100, 2 and 50, and 4 and 25. Hey, there's our pair. We'll do negative 4 and negative 25. So this time on the box, we want to do x squared, because x squared times x squared gives us x to the 4th. So instead of having just x's for our middle terms, we're going to have x squareds for our middle terms. There they are. And just like before, we want to pull out our common factors. So what goes to into x to the 4th and negative 4x squared? X squared. Down here, we're going to have negative 25. Then when we're looking at x to the fourth and negative 25, x squared, that's going to be x squared again. And then our common factor of negative 4x squared and 100 is negative 4. Okay, so x squared minus 25 and x squared minus 4. Now it's really easy to make a mistake here and to forget our negative 2x. What we're actually going to do is put all of that together, and we'll have negative 2x times x squared minus 25, x squared minus 4. And we did figure that out Wednesday night. We just didn't figure it out using the box. And then from there, we were able to set those equal to 0 to find our factors and to find our multiplicity. My favorite method for factoring is actually something called factoring by grouping, and it works for this example as well. It'll work for any that can be factored. So once again, just back to this problem that we just did, our first step would still be to pull out the common factor. So 2x can go into every one of these terms. Then when you're doing factoring by grouping, you again look at the first and the third term of your trinomial. So your x to the fourth and 100. In this case, it's just 1 times 100, so we're just looking at 100. And we already said before that our factors that sum to negative 29 are 4 and 25, so I'll just go ahead and write those down. So to do factoring by grouping, instead of using the box, what I would do is have x to the fourth minus 4x squared minus 25x squared plus 100. It works the same way as a box. It's written out in a linear fashion. What we're going to do is just take a look at these two terms and these two terms. We're going to look at it almost as if they're separate functions, even though they're not. They're part of the same polynomial. So what we want to do, I'm just bringing down this 2x, is say, well, what's the common factor of x to the fourth and negative 4x squared? It's x squared. X to the fourth divided by x squared is x squared, and negative 4x to squared divided by x squared is just negative 4. So I just pulled my common factor out of those two terms. Now I want to look at my next set here. So negative 25x squared plus 100. So I'm going to think, what factors can I pull out here? It looks like negative 25. We'll go into both of those. We got to be careful here because we're dividing by a negative. So 25x squared divided by negative 25 is x squared. 100 divided by negative 25 is negative 4. Now what we're going to do is take our coefficients that are in front of the parentheses, the ones that are outside of the parentheses, and put those together. So that's where we're going to get x squared minus 25. It's kind of like we're undistributing this. That's really what factoring is. And then what will always be true when you do factoring by grouping, or when you use the box really, that term is going to repeat. We have x squared times x squared minus 4, and we have negative 25 times x squared minus 4. That's why we're able to write x squared minus 25 times x squared minus 4. Now we're totally factored. So just like we found on Wednesday, there's going to be 5 x-intercepts to this polynomial, and it's going to go through each one of them. And it's negative, and it's odd. Here's a couple of formulas that you'll want to keep in mind. These are what we call perfect square trinomials. And they always follow the same pattern. We talked a little bit about these on Wednesday. The only difference is that the top one has a plus sign and the bottom one has a minus sign. You don't actually have to memorize these formulas because you can get them by foiling, by multiplying. Let me show you what I mean. Let's look at an actual example. Let's say I had x plus 4 squared. Well, I could use my formula and say that's x squared plus 8x plus 16. Using the formula is really a shortcut. The long way to do it would just be to do x plus 4 times x plus 4. And when I multiply these terms together, I'm going to get x times x is x squared. X times 4 is 4x. We have another 4x and a 16. So it's going to come out to the same thing. Using the formula is just a shortcut. So here are your formulas. They will come in handy. So just be aware that they are there. They can be helpful to memorize, but you don't have to, because you can always just multiply the terms together to figure out what your expanded polynomial would be. Of course, you also have the difference of squares, and this is one that you're really familiar with. Oops, that's not what I meant. There we go. What I meant was a squared minus b squared. And you're really familiar with this one. You know that a squared minus b squared is a minus b times a plus b. So earlier I said that I copied down the problem wrong or forgot a negative sign with that mistake that I made at the end of the day on Wednesday. Well, here's the problem that we were working on, and we started out really well on this. The first thing you want to do is see if there's any common factors, and this does have a common factor. Now, here's what I did on Wednesday. I figured out that negative x to the third was the common factor, and it is, and then I wrote down this. Do you see the mistake? Negative x to the fifth divided by negative x to the third is x squared, but negative x to the fifth, 5x to the third divided by negative x to the third shouldn't be negative 5, it should be positive 5. That's where I went wrong. I had a negative there when I needed to have a positive, and that changes everything because x squared minus 5 does have factors. X squared minus 5 equals x minus 5, x plus 5. That's why I thought that this was going to have x-intercepts at 5 and negative 5, but it doesn't. The reason that this doesn't have x-intercepts at 5 and negative 5 is because x squared plus 5 doesn't have any real solutions. If we were to set that equal to 0, we would get x squared equals negative 5, and then we would have the square root of negative 5, positive negative. So our answer would be imaginary. So you were correct. This one only has this one x-intercept, and it's going to be at 0, and it's going to have a multiplicity of 3. You were right. Well, thanks again. Hope you're having a good weekend. I will send you a couple of links to some really good factoring notes that I found on the internet, some that I really like. And thanks again for watching Little John John. See you tomorrow at church. Bye.